All right, what's up everybody? We're going to start off with a little bit of a different warm-up. This one we're going to talk about something called prime factorization. I'm about to be running out of room. Great start to the video, Mr. Collier. All right, so we got prime. Let's give myself a little bit more room. Factorization. Okay, now, you don't necessarily need to write that. It's not even something that you need to like memorize the words for, but it is what we're going to be doing. Okay? Has anybody ever heard of a prime number before? Okay, prime numbers are basically like the tiny little building blocks when it comes to numbers. Okay, for example, 1, 2, 3. These are all prime numbers because the only thing that you can divide these numbers by is either divide it by 1, which doesn't really do anything, or divide them by themselves. The number like 4 is not a prime number because you can divide 4 by 2, right? And so 4 is not a prime number. 4 is a number that you can build with other numbers. You could say that 4 is 2 times 2. And so that's what makes 4 not a prime number. Now what about 5? Is 5 prime? Yes. What about 6? Can you build 6 by multiplying two numbers together? What can you multiply together to make 6? 2 times 3 makes 6. So 6 is no good. What about 7? Is 7 prime? 7 is prime. You can't multiply any two other things together. What about 8? No, 8 is not prime because you can multiply 2 times 4 to get 8. Right now we're doing a little every other thing because all of the even numbers will not work because every even number can be divided by 2. What about 9? 9 is an odd number. Is 9 prime? No, because 9 is 3 times 3. And so you can tell prime numbers are getting a little bit more rare. What about 10? Well, 10 is an even number. 10 can be divided in half. It's 2 times 5. 11 is the next prime number. Now, we're just going to kind of stop here, okay? Here's what I want to show you. Prime numbers, in particular, 2, 3, and 5. These are the numbers that you're going to want to really memorize as being prime numbers. Almost every number that's not prime can be built out of 2s and 3s and 5s. So, if I give you the number 20, okay? Is the number 20 prime? No, because the number 20 can be broken up into two numbers. What two numbers can multiply together to make 20? And here's a way you can do this. You can try to think in your own head. If you're really good at multiplication, maybe you can think of a couple different ways to make 20. But the easiest way to do it is to go to Desmos and start with 20 and then hit divide and then just try 2 or 3 or 5. I like to always start with my 2 and work my way to my 5. So 20 divided by 2. Does that work? Yes. 20 is obviously 2 times 10. And then I'm going to move on and I'm going to start working on this 10. My goal is to keep breaking everything down into little crumbles until the only thing left is 2 or 3 or 5. Those are the numbers I want to find. These are supposed to be arrows, not ones. So 10. Does 10 divide by 2? Yes, 10 divides by 2. It is 5. So I'm going to put 2 and 5. And now, I've broken this down until I got a 2 and a 10, but then I broke the 10, and I got a 2 and a 5, and at this point, all the numbers at the bottom of my little breakdown are all prime numbers. I have 2 and 2 and 5. Now, this is called prime factorization. Here's why. What is 2 times 2 times 5? It's 20, okay? In mathematics, sometimes we say that the prime factorization of a number is kind of like seeing that number in its purest form. Instead of seeing 20, we're seeing it all the way breaking down. This is like the Legos before you put them together, and 20 is like, after you put them together. Today, we're going to be using the prime factorization, and so you don't necessarily need to know this big fancy word, prime factorization, but you do want to know how to break this stuff down. Now, the only thing I want to point out before we move on is once we break down the 20, we're not going to use our 20 in our prime factorization because 20 is not prime. Once we break down the 10, we're not going to use the 10 because the 10 is not prime. Any number that's on top of these triangles, we're never going to use them. And we know we're done once we get to a prime number, a 2, a 3, or a 5, that's already there. Okay, so let's try this one. Instead of 20, let's try 48. Okay, really simple. Go to Desmos, type 48, divide, and then just try 2. And if that doesn't work, try 3. And if that doesn't work, try 5. So divide it by 2, and you get 24. So draw your 2 splits, a 2 and a 24. And then that 48, as far as I'm concerned, we don't really need that 48 anymore. Now the 2, this is a prime number. So this is a dead end. But what about the 24? Is that prime? No way. Just keep going until you get 2s or 3s or 5s. We want to get all the way down into 2s, 3s, and 5s. So break it down. Does 24 divide by 2? Yep, because it's 2 times 12. We don't need that 24 anymore. We only want the primes. What about 12? Break the 12 up. 2 times 6. We don't need the 12 anymore. What about the 6? Break the 6 up. 2 times 3. We don't need the 6 anymore. And so what you have now is 2, that's prime, 2, that's prime, 2, that's prime, 2, that's prime, 3, that's prime. And you have all prime numbers left. All of them, that's 2, and another 2, and another 2, and another 2, and a 3. That is 4 2s and a 3. That is 48 in its like pure form. We broke all the Legos down. 2 times 2 times 2 times 2 times 3 is 48. Okay, this is like the pure broken down 48. Okay, prime factorization, breaking these numbers down. Now let's do one more. Let's do 45. The very last one we're going to do on this warm up. Stay with me, help me out here. 45. Is 45 prime? I'll give you a hint. If it's not the number 2 or the number 3 or the number 5, it ain't prime. We're trying to break it down. So with this 45, can you divide 45 by 2? If I go here, 45 divided by 2, it tells me a decimal. So what do I do instead? If 2 doesn't work, check 3. What's 45 divided by 3? 15. Okay. So I'm going to break this 45 into 3 times 15. There really is not a lot of brain that I'm using here. You just go to Desmos and you try to divide that number by either 2 or 3 or 5. Up next is 15. Break it down. 15. Does 15 divide by 2? Nope. Try 3. And you get 5. 3 and 5. And once you get to the point where you have a 2 or a 3 or a 5 right here, you're done. Because you've now broken it all the way down into only prime numbers. We don't need the 45. We don't need the 15. We're looking for 3 and 3 and 5. 3 times 3 times 5 is 45 in its very simplest form. Yes, of course. Alright, that's going to kind of end our warm-up on prime factorization. Break down your numbers until they're in their little tiny little Lego bits. Just divide it by 2 or divide it by 3 or divide it by 5. Now, the very last thing before I end this video, before I pass out the notes, is that we talked about 2, 3, and 5, and almost every single question is only ever going to use 2, 3, or 5, but there is a small chance that you might need 7. This is that's another prime number, but it's just a lot more rare. 2, 3, and 5, these are like your normal Lego pieces, and then 7 is like those really funky colored, you know, crazy shaped ones. Okay, I'm going to end this. This is prime factorization. Break your numbers down.